Hello and welcome back to another episode of From the Field. I'm your host, Casey Orr, based in Wellington, New Zealand. Yes, I actually just realized that I have a ladder in the background. Should have probably moved it. I have been doing some DIY around the house recently and need to get into an awfully spacious attic, which I don't know why it's so huge. But anyway, I'm digressing from topic. Today we are going to be covering off the great topic of IoT, which is pretty much everywhere these days in your toaster, your watch, your phone. Actually, I don't. Is your phone classified as an IoT device?
I would say so.
Yes.
Yeah, okay, we'll go with that. It makes me sound smarter than I really am. Cool. So we're going to be talking about IoT and the world of like fault tolerance and of that fault detection. Sorry, not tolerance. I guess tolerance is in there. Scott, why don't you give yourself a quick introduction before we hand over to Rohan to do the same, and then tell the audience what they have to look forward to.
Sure. Hi, everyone. Yeah, my name's Scott Patterson. I'm a solutions architect here at AWS. Also, somewhat of an IoT specialist. I'm actually so. Thanks for having me back, Casey. I'm got to say I'm a little bit surprised.
Oh, yeah, that's true. I actually forgot that your name was on a blacklist. So, but I'll have you back. You can actually earn your stripes again. I
Thank
think.
you. I am the only one wearing an AWS t-shirt today. Just saying.
Mm,
But we'll let that one slide. I'm real keen to learn from Rohan today. Um, Give us an intro.
cool. Hey everyone, I'm Rohan. I'm also a solution architect here at AWS, based in New Zealand. Um, and yeah, today myself and Scott we're going to take you through, like Casey said, um, how you can use IoT on AWS to do fault detection. And we're going to focus on a customer or an imaginary customer use case. And we're going to step through the process of how we solve kind of the challenges along the way.
And you're doing a few demos. Are we going to be looking forward to the same level of demo that we had about a month ago when we had was it a IoT cat feeder that was feeding Chris Barron coffee
Chiwai.
beans and yeah, Chihuahua, yeah, feeding Chris Barron like coffee beans and Skittles. I think they were.
I think ours is going to be pretty basic. Like it will show you the basic use case, but then we'll
Mm.
take it next level and show you where this can really go.
Nice. Okay, cool. I'm going to look forward to it, but I'm a bit upset that none of you are going to be eating coffee beans at the behest of our audience.
Cool. Let me just get into here. Cool. Yeah, so I already introduced myself. I'll just get into it. Yeah, we're going to talk about fault detection on AWS using IoT. I want to start with just talking about what IoT is, if you're unfamiliar with it. So IoT, or the Internet of Things, basically is a network of connected devices that are, communicating with each other and generating data and generating insights based on that data. And yeah, the landscape really consists of the physical devices themselves, like sensors collecting, different data points like temperature or humidity or whatnot. Could be things like cameras, machinery, factory equipment, anything really that can collect data from the environment that we want to look at. And also applications, right? And these are the things that take in that data, analyze it, and generate insights. So, like I mentioned before, we're going to focus on a scenario today as we kind of step through this use case. And we're going to be in the shoes of Joe, who is an imaginary IT manager at a restaurant chain. You can see the photo on the right. Scott generated that using, was it Stable Diffusion, Scott?
Yeah,
What
yeah,
was that?
yeah. So
Yeah.
the reason why Joe's looks a little bit funny in his face is I did generate this in a stable diffusion model using Amazon SageMaker Jumpstart, so you can deploy your own model and generate your own images. I think it's got the fridge quite nice. It doesn't look
Yeah, it
like
looks
my
good.
fridge. There's too many veggies in there.
Mm.
But he looks pretty proud of it nonetheless.
Yeah, yeah. So that's Joe. And he's the IT manager of a restaurant chain. And basically, what they want to do is they have a lot of food spoilage in their refrigerators. Like occasionally, the refrigerators fail, um, and it causes about $100,000 in losses, right? In terms of the food inside going bad and also having to repair the fridge. So we want to try and fix that issue, right? So the fridges have temperature and humidity sensors in them, but they're not currently connected to any other system, so they're not doing anything with that data at the moment. And what Joe wants to do here is really see the status of all the refrigerators that they have in their restaurant chain and receive an alert when the temperatures are outside of the normal range, and notify the restaurant staff to take some action based on that, whether it's moving the food to another fridge or maybe someone just left the door open and they need to shut the door, right?
Just by the way, I worked at a supermarket, and when the freezers and fridges failed, that sucked. Because I obviously was the one having to move all of the frozen stuff, and there wasn't enough. There wasn't enough, like, warm clothing to go around, so you just had to do it bare hand.
uh,
That was great. Great,
It's
great memory
generally a
for me.
reactive process as well, right?
Yeah.
So you only notice when like you don't hear the compressor anymore and like you start seeing drips and stuff going on the floor. So imagine if we had some data that could, I guess, alert us to the fact that something is going bad.
And they also
yeah,
do really interesting things as well. So, like, when the fridges are struggling, they'll actually will heat the top of the building to force the colder air down. So it's like really
crazy,
counterintuitive. So it's
crazy. But yeah, so I mean, it's obviously like a very real problem, right? If Casey's supermarket had some kind of IoT system in place, maybe he wouldn't have had to shovel bags of frozen veggies between a couple of fridges. So hopefully we can solve for that, right? And in terms of the challenges that Joe's facing here, to put that in place, so they've got a number of a range of different types of fridges and sensors across their business, across all of New Zealand, and he wants one standardized way to connect and manage all of them from the cloud, right? He doesn't want a bespoke thing for each type of fridge they have. So that's the first challenge. They also need somewhere to store that data. So they have an existing MySQL database, but that might not be the best choice when dealing with time series data. So we'll need to solve for that as well. And finally, they don't have any kind of data visualization tool to monitor the IoT data with and raise alerts, right? So those are the three challenges we're going to solve for today using AWS IoT services, and we'll do a bit of a demo at the end. Sound good?
sounds
Cool.
great.
Keen.
Looking forward to it.
Awesome. So let's start with the first one, which is around the fact that they've got a range of different types of devices, and we want like a standardized, centralized way to manage all of them. So we can use IoT Greengrass here. And what that is essentially, it's an open source runtime developed by AWS that you can run on your edge devices and then deploy components to, whether it's a Lambda function or a container or something like that. So we can use this to have one consistent runtime across all the different types of fridges and devices that we have, that we can then deploy any of our collection or processing scripts to, right? And it can run on a pretty wide range of devices. So from anywhere to something really super small, like a Raspberry Pi, to an edge server or something even bigger than that, right?
Like a fridge.
Like a fridge. I think though in Joe's case, the fridges do have temperature sensors, but they're not necessarily like a computer. So we might need a device to connect up to the refrigerators, get the readings from the sensors, and then send them onto AWS. So we can have some sort of edge compute device, something small that can connect up to the refrigerators. We can install Greengrass onto it, deploy our collection script there, and then have that send the readings to AWS, right? I want to pause here and ask Scott, what other options do we have here? Like, do we have to use green grass? Are there any kind of alternatives you can use, and when would you use those?
Yeah, so I guess to address this, what we're really talking about here is microcontrollers versus microprocessors. They're a little different, so let's do a quick definition check to see what we're working with here. So, IoT devices are powered by embedded processors called microcontrollers and microprocessors. MCU or microcontroller is a single chip containing a simple processor. Can't do that much. A microprocessor or MPU is more like your traditional compute. Maybe it runs Windows or Linux or its own ARM architecture, things like that. And the reason that matters is because of the operating systems that are suitable for each platform. So we've talked about Greengrass, which actually runs as a runtime on top of an operating system. Um, but for MCUs like this expressive ESP32 or
Let me make you bigger.
yeah, yeah, or the Seed, I really like these Seed Studio ones. They're about the size of a thumb. Um, they You can run free RTOS on those or the C SDK to easily connect. For MPUs, like what have I got here? Like a Raspberry Pi, that kind of there's Raspberry Pis inside, or here's an Intel Atom based microprocessor. So this is actually a deep lens, but yeah, Intel Atom computer in here. That's the sort of thing that would run Greengrass, or the AWS IoT SDK to connect into AWS IoT Core. Um, Casey's got some goodies
Yeah.
too.
I found you made me remember because I also have the Jetson Nano,
Oh,
which
Oh,
cool.
is
nice.
awesome. Which I'll take out and just show off as well because these are cooler devices. Really hard to get, and this is still like a tiny one. So it got like the little thing there. And these are really
Neat.
cool. They're really nifty to do like little models on the edge. I even got like a little tiny fan on it because like the heatsink wasn't keeping up with the level of brutality I was inflicting on it.
Neat. So you might use where this kind of fits in for Joe is you might use a little microcontroller connected to a sensor. You're talking to that sensor over I squared C, SPI, that kind of thing, um, and then you might have 50 of these sensors around the different fridges and various other use cases. You might collect them and aggregate that data into an edge compute device. And you can do various things there, like filter out things like that. You can fire alerts straight from that device, or you can take actions from that device, or you can even use Greengrass to deploy machine learning models. So you can do that machine learning on the edge. So you might look to forecast failures, that sort of thing, from the data you're getting from your microcontrollers. So maybe do we have a slide on FreeRTOS? Let's talk about more about that.
We do.
Um,
Casey, do you want to
yeah,
pull that
before
up?
I
I
do
should
that,
be
can you
sharing it.
move slightly to, I think you're right, just because there's a dog in the background, which is way more important than you.
Ah.
Oh yeah, this is Hank. Hey Hank,
Nice.
he just chills. He's a big boy.
Mm. Sorry for a little
He's u-
distraction. There you go.
he's used to me sitting here all day.
Just chilling out.
Yeah. So a bit about FreeRTOS. It's a real-time embedded operating system, runs on microcontroller platforms, and I would say it's leading the MCU RTOS category. So we at AWS took stewardship of the open source project a few years ago. We're actually honoured that Richard Barry, who invented FreeRTOS about 20 years ago, has joined AWS as the senior principal engineer, still working on FreeRTOS, and we continue to invest in that project. So it's in good hands, and you can run it on your stuff. It's mostly written in C, which makes it fairly easy to port over to a different range of microcontrollers. And there's a whole bunch of libraries that are out there in the community. Some supported by us as well. So a couple of examples of where it's used. Traeger use FreeRTOS in their pellet grill barbecues to send temperature information to their app. So when you log on to the app, and control the temperature of your barbecue, your fancy internet connected barbecue. They're using FreeRTOS on the other end. Same for Balkan iDevices. So they're the smart light switches integrated with Alexa. Oh, stop. Alexa. Yeah, they use FreeRTOS there. So enough about that. Back to you, Rohan.
Yeah, cool. So it sounds like in Joe's case, we might need to use a mix of FreeRTOS or Greengrass, depending on the specific device that they have for the fridge. Cool. Now that we've kind of talked about the devices themselves and the software running on them, the next step is really about having something in AWS to receive that data that they're sending, right? And we can use AWS IoT Core here, which is essentially a service that lets you connect, manage, and scale your device fleets easily without having to worry about the infrastructure that sits under them, right? So Joe, in this case, can connect up his local devices to IoT Core, collect the messages coming in from them, and route them to the appropriate destination, right? So IoT Core essentially acts as like an MQTT broker here, and it works in a pub sub model. So the devices that are sending the data and the applications that are receiving it are decoupled. And you can send messages both ways, right? So we can receive the data coming in from the devices and the temperature readings and whatnot. And we can also send messages back to the devices if we need to, change some kind of configuration or setting or whatever. There's that two-way communication through IoT Core. You can also, there's also quite a flexible rules engine there. So you can route messages to a destination from IoT Core depending on the rules you configure, right? So in this case, Joe could route the messages coming in from the fridge to different services on AWS for processing or analytics or whatnot, or alerting if anything's out of the ordinary. And if Joe had like a third-party application that you want to use downstream, like Salesforce, for example. I don't know if you send IoT data to Salesforce, but key messages, we're not just tied to AWS services here. You can send messages to third-party applications. Scott, on IoT Core, is there anything that you think is important to talk about?
Yeah, let me think. Yes, it does have quite a lot of features packed in there. It's used for a lot of users. There's a couple I'd touch on. There's a lot of different ways to manage devices once they're connecting into AWS. Something that's really good in IoT Core is the registry. So it's where we can catalog all the devices that we've got. If Joe's got 1,000, that's 2,000 devices. It's quite hard to manage. So we can do things like run indexing over those devices so he can search across the whole fleet, figure out which ones are behind in their firmware updates, and then go and create a job to push out the updates to those devices. There's also device identity management, which is a really important topic and something that we take care of you quite well, take care of for you quite well as well. And that's where we'll generate the certificates that you can load onto your device, and that enables the authentication and the connection there. And then on the cloud side, we can attach IAM policies to that certificate saying what the device can do, like which MQTT topics can it publish to and subscribe to, can it push to an S3 bucket, that sort of thing. So it's really powerful to do the authorization on the cloud side. And then there's a bunch of provisioning options when you look at doing bulk registration as well.
Cool. So it sounds like IoT Core is quite a good fit to kind of be the central place to connect into all our IoT devices and send those messages to the right place on AWS, right?
Yeah, I think it's worth calling out that we've talked about Greengrass today as being a runtime for the device. It's actually a cloud service as well. So they kind of work hand in hand. And with Greengrass, you can package things like a Docker container and then do a deployment and you can create that deployment target as a group of devices. So if you had an update to do to all of your edge nodes throughout your New Zealand restaurants, you could create that group and then deploy to the group, and it would go and deploy to all those devices. So Greengrass, the cloud side, is how we manage Greengrass devices.
Cool, cool. If we go back to the challenges then that we talked about to start with, it seems like we've kind of ticked off the first one. Using Greengrass and IoT Core, we can connect up to and manage our IoT device fleet across all the restaurants that we have and all the refrigerators. We can manage those from the cloud. Let's talk about the next challenge, which is around the data store, right? So once we've received all those messages in IoT Core, where do we send them off to store that data and then eventually make use of it? Now, we know that Joe has an existing MySQL database. The thing with a traditional relational database is that they aren't really efficient or really optimized for working with and querying time series data. So if we want to use the best tool for the job for this specific use case, we might want to look at something that's kind of purpose-built for handling that kind of data, right? So if you look at a time series database, those are kind of optimized for storing and querying data that changes over time. And the service we have on AWS to our basically managed time series database offering is Amazon TimeStream. Essentially a purpose-built serverless time series database on AWS that Joe could use in this use case to store all that time series data coming in from those sensors. And because it's serverless, Joe wouldn't really need to worry about provisioning or managing the infrastructure that sits under that database. Joe basically wouldn't need to spend time maintaining or managing that underlying infrastructure on an ongoing basis. It's also very scalable, right? So TimeStream is capable of handling like trillions of events daily and executing SQL queries on those quickly.
There's a lot of fridges.
Yeah, yeah. And like in this use case, like we might not have trillions of events coming in daily, right? But that scale is quite important because, if we're collecting regular readings from these industrial fridges all across the country, and, let's say in the future, we want to be able to add new use cases where we're collecting more data and doing more things, we want to be able to handle that volume of incoming messages, right? So that scale is quite important there. So we can use TimeStream for Joe as a data store, right? There are, if you want to look at other open source time series database options, those do exist. We're going to use TimeStream here. It has native integration with IoT Core, so it's really easy to set up the message routing from there. Yeah, that kind of solves for the second challenge, right? Around storing their data.
Yeah, Rohan, also to your earlier point. So if you're taking a reading every 5 minutes, then over a year, that's 105,000 data points for one device. So
Exactly.
over time, it adds up quite rapidly.
Yeah. And that's where kind of picking the right tool for the job kind of makes your life easier and less wasteful of resources, I guess. Cool. So we're on to the last challenge now, which is around visualizing the data so that, the restaurant managers can be alerted when the temperature of a fridge is outside of a normal range and then, take some action on that. We could use Grafana for this. So Grafana is an open source analytics and monitoring tool for databases. It's a pretty popular option for time series data, like the data that Joe is working with here. And we can use Grafana to build a dashboard and monitor Joe's refrigerators and then alert when there's a risk of the food inside spoiling, right? Now, on AWS, we have a service called Amazon Managed Grafana, which is essentially a managed version of Grafana on AWS. Lets you offload the operational management of Grafana by handling the underlying infrastructure and scaling that as appropriate for you without you having to worry about that. Integrates quite well with other AWS services like TimeStream, so it just makes it quite easy to set up. And we can look at that as a visualization tool, right? I'm keen, Scott, to get your perspective on, using Grafana versus something like QuickSight or other kind of BI tools for visualizing this kind of data. What do you
Yeah, okay.
typically see in the space?
Okay, so you could look at Amazon QuickSight. I've got quite a lot of customers using that. And then you could use Athena if you want to pull in extra data, from S3, from your QuickSight dashboards. Possibly you've got multiple different databases with kind of sources of record and asset data that you might want to pull in for your dashboards. Or if your company has a visualization tool already, like Tableau or Power BI, then you can use the TimeStream ODBC driver to pull that data just like you would any other database. We like Grafana because it's open source, and then that managed services is there, so you can quickly stand it up, and you don't have to mess around setting up servers.
And one
Yeah.
of the other great quotes for Grafana is that there's a lot of pre-built dashboards out there. It's like, for example, for VPC flow log visualization and other like logs that are produced, there are like completely built out dashboards already, which makes Grafana adoption a lot easier. But of course, this will be a little bit more custom than that.
Mm. Cool. So we made a good choice picking Grafana, it sounds like. But let's take a look at the overall solution that we've kind of got so far. Actually, I'll come back to I think my slide order messed up. Whoops. But just coming back to the challenges, we've ticked off all the final challenge around visualizing the data and raising alerts. We've ticked off all three. I'll go back to the solution slide now and just talk about the end-to-end solution before we do a bit of a demo. So on the left, we've got our temperature sensor and our devices that are collecting the data and sending it to AWS. We've got IoT Core set up to receive that data and route those messages to TimeStream to be stored. And then we're visualizing that data with the Grafana dashboard through Amazon Managed Grafana to visualize and then set up alerts. So what I'll do now is I'll jump into a bit of a demo. Let me just pull this up.
Nice.
Nice. Is that coming through? Perfect. So unfortunately, I don't have an industrial fridge with temperature sensors available to demo with,
That's just
but
unacceptable. Unacceptable. You should have gone out
it
and
is
brought a fridge just for
unacceptable.
this. Or like even being at home and pull apart your fridge at your flat or home.
Maybe an
Yeah,
industrial beverage fridge.
Mm.
yeah. Um, yeah, I mean, I wish I could, but the next best thing is a simulated device to send that data, which is what I've got in front of you guys right now. So I'll just make this smaller.
And hi there.
Essentially, oh, go ahead, Casey.
Oh no, I was just saying hi to someone
Awesome.
that popped into the chat.
Yeah, cool. But basically, I've got a simulated device running a Python script that's generating kind of dummy data. You can see that data here. It's got a timestamp, a location, a temperature, a pressure reading, and a humidity reading. So this is generating that data and sending it to AWS, right? This is just a Python script.
But is this a pressurized fridge? Like it's
Well,
hermetically
I looked
sealed.
it
Like
up.
give me a code and pressure.
So I looked it up. And industrial fridges do like maintain their pressure around.
30 psi.
Oh no, sorry. Yeah. Don't worry about the pressure. The
Is that
humidity. Yeah, just pretend it's a pressurized fridge, you know?
It's data. It's data.
Yeah. Um, yeah, but essentially the script is generating dummy data on the temperature, humidity, and pressure of the fridge that we're then sending to AWS, right? It's just a Python script. Scott, in terms of the script, that we would run on the device to collect and send the data to AWS, like, if we were running on FreeRTOS or Greengrass, like what options do we have there in terms of language and all that sort of stuff?
Yeah, so typically with FreeRTOS, you'd write, I guess, in C, and use libraries there. So there's MQTT libraries and things like that. Also, some of the smaller devices support MicroPython now, which is really neat. So it makes it really fast to get started because Python is fairly easy to jump into. But then on Greengrass, you could write it whatever you want. Python's good because we can just obviously pull in the IoT SDK, but you could write it in Node.js or Bash if you wanted.
Cool.
And hi Hart, it's been a while since I last seen you. Don't worry, yeah, the code stuff, it's just more about the intent of the code rather than
Yeah,
understanding it.
yeah.
I love the time when people bring up code on the stream, I just nod my head too. And
Yeah.
I
Cool.
work with weather centers, so that's pretty
Oh,
cool.
interesting. Okay.
Nice.
There's a question around data storage in there. I will get to that very shortly. So yeah, I'll touch on that in a second. Um, but yeah, we've got this code that's sending these messages to AWS, and I'll just show you in IoT Core. We've just got an MQTT test client here to showcase the data that's being received, and we can see that this is the data that's coming in from the fridge. It's being received by AWS. So these are the messages that are coming in essentially, right? Yeah, it's over MQTT. And what we want to do then is take these messages and store them somewhere. So if I go into the message routing rules that I've got set up, I've set up a routing rule to essentially just take those readings that come in from temperature, pressure, and humidity and store them in time stream. So time stream, like I mentioned before, purpose-built time series database on AWS that we can store our data in, and then visualize the data with a Grafana dashboard off that.
Can we take a look at the actions and the options available? So obviously this triggers based on, yeah, it selects temperature, pressure, and humidity from the incoming JSON, and then it's doing an action based on that. So we've got action one,
Yeah,
and
so
and
there's
you
a lot
can
of
see you can have multiples. Cool.
yeah, and there's a lot of things you can do, right? Like you can insert the message into a DynamoDB table, you can trigger a Lambda function, you can send a notification to SNS, a bunch of options here to take action on that data that's coming in. If something isn't in here that you need it to do, you can probably just write a Lambda function to do that. So it's quite flexible in terms of what you can do with that data. What I've got here is just writing the message into a time stream database that I've set up.
Awesome.
Yeah, cool. What I can do then is so I've got the time series, the time stream database set up. I've got Amazon Managed Grafana as well. That's visualizing that. So I guess I'll show you that because that's probably more interesting. And I've set up a dashboard here with the IoT fridge data that's coming in. So I'll just refresh it. And we can see that the device temperature, it's kind of in the green range. It's about 4 degrees Celsius. That's good. That's what we want. You can kind of configure this dashboard with whatever you want. So I can add a panel and do a different visualization there. I've got the gauge here. I've just got a table with the recent entries for the last 1 minute in here. It's quite customizable. You can do a lot with it. What I'll maybe do is I'll change the script and change the temperature reading from 4 degrees, which is kind of in the normal range, to something that's not in the normal range.
So you're going to change the how it's generating this random data, I guess, generating anomalous or a bad random data.
Yeah, so I'll change the temperature of the sample data to be around 9 degrees, and I'll just restart the script. So now if we go back into our MQTT test client and just give it a second, like we can see the temperature readings that are coming in now are a lot higher than they were before. Before it was about, 4.9 degrees. Now it's about 9.9. And that is something that we don't want, right? We don't want the temperature to be that high. So how do we react to that?
And
Um,
while you're
uh,
doing that as well, Scott, there's a question for you in the chat, which I think would be very apt for you.
Oh yeah. So the question is, when I joined AWS, did I already specialize in this field, or did I have a base understanding, expand on that as I went? Look, that was it's something that has kind of grown organically. Working with various customers at AWS, I get to work with a lot of customers and they're all doing really cool things. I got really excited about what customers were doing with IoT. It's spawned my passion for it, and I started building things at home and really got geeky about it. So um, now I call myself a specialist, I guess. Uh, yeah, Rohan.
cool. Yeah, and I work with Scott on a lot of these customers as well, especially in the last kind of few months. Anyways, we've got the data that's coming in that is higher than normal. I've got another routing rule here. That's the alert rule. And this basically, if the temperature that's coming from those fridges is above 8 degrees, that's kind of outside of the normal range that we want. I've just set an action to send a message as an SNS notification that I can then, subscribe to, get a text sent to me or an email or whatever. So the restaurant manager in this case could get a text saying, "Hey, the fridge temperature is abnormally high. You should go check it out." Um, so that's how we can alert the store manager based on that. And if
And
I
for health
go
and safety
to
reasons, I really hope it's lower than 8 when he gets an alert.
yeah, 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 yeah. And if I just go into the dashboard here and refresh it, like we can see that, now that the data is a lot higher, it's in the red. It's 9 degrees. We don't want that. It's too hot. So this is kind of the dashboard view of that abnormal data.
So Joe can monitor the temperatures of all of his fridges while he's on holiday. I think
Yeah,
a
yeah.
real world use case would here. I think one of you mentioned it before, was actually flashing a light or taking an action that would trigger someone to do something um,
Mm.
in the store. It would be a good use case.
Yeah, maybe a big like red alarm, blaring. It could be a
Yeah. So that's where
could
we could send another control message down MQTT for that microcontroller to go and turn on or flash a light or something like that.
yeah, cool. So yeah, that's more or less it. It's quite a basic use case, but I think it's important to show kind of the simplest form. Um, what I'll do now is let me just jump back to this. So we had a look at this quite simple use case. We solved Joe's problem, right, of being able to alert when the fridges are outside of a normal range. Now, what if we wanted to take it a step further or a few steps further, right? What if we wanted to build a full digital twin of their restaurant, or let's say they had like a food manufacturing plant, and they wanted to set up IoT in a way that they can kind of monitor everything that's going on in there and optimize the production flows and any blockages or anything like that. Like that's where they could set up a digital twin of that factory, and take all of that data in, coming from all these different sensors and data sources and video feeds, and visualize that in a way where they can optimize their factory or their production line or their kitchen, like restaurant processes, right? We've also got a bit of a demo for this, so maybe I'll hand the screen over to Scott to talk you through what that looks like and what you can really achieve when you go all the way with this technology, right?
Yeah, okay. I guess we're stretching a bit here, taking this real basic use case and going, okay, what can we do with this? Where can we scale this to? Like once we have this data coming into AWS, you can do unimaginable things with it. Um, this demo here is for a digital twin for a cookie factory. So they've stepped up their game. Not just doing groceries at the moment. They're doing actually food production. And we've got a team actually monitoring all these different factories and the production plant. So we've got a role here, Sal. Um, Operations manager. So let's go into here. This demo was built with AWS IoT App Kit. So um, it's uh, it's it's on GitHub, and you can build rich UIs for your digital twins and for your monitoring. So look, which location we're going to choose? Central Bakersville. So we're making cookies. It's got to be at Bakersville, and we've got kind of an overview here. So I'll just click the scene because it might take a little bit to download. With a digital twin, we can actually import into TwinMaker. We can import CAD models and 3D representations of our real world thing. And then they take a little bit to download for the first time you open them. But in that way, we can, so if we have a cookie factory, we can actually tag on the machine or on the piece of equipment. We can create a tag and then attach a data point to it. So we might actually be able to find that fridge in the restaurant chain and go, this is the specific temperature of this fridge. So it's just come up now. Let me try and orient to, this is my cookie factory. Hopefully this is coming through okay. And we can see we've got on the left, we've got a bunch of dough mixes there, and we've got a bunch of lines here. So let's have a look at this one. This one's got some tags on it. Just trying to get it all nice. And zoom in a bit. Here we go. So we've got some conveyor belts, vertical conveyor, box sealer. So it looks like it comes, the cookies come down. This here is a freezer, so they come down the line. Yeah, the cookie former, they come down the line, they get snap frozen in the freezer, and then they go and get boxed up. So we can see this process as well in a hierarchical model. This comes up, and we can see the relationships between all the different machines. So we've got the cookie former that feeds into the freezer tunnel, which belongs to a freezing model, conveyor vertical, things like that. And if I hover over things, I can see, the freezer tunnel, it's going at 5 revs per minute, and it's really cold as it should be. And if I click on that, I can see what's connected to all of this. I'm hoping it kind of goes wrong soon, because then I'll be able to show you something different. And then if I click on the dashboard, we can see all the history of this freezer tunnel as well. So you can see it has some spikes of going high and then it goes low. Maybe it's had an outage or something like that. You can see that when the RPM is 1, we've got an alarm status here. So oh, look at that, it's just turned red. So look, if I go back to, if I click on there, I can see the speed has now gone to 1, so it's stopped for some reason. So we're now in alarm state, and you can see these different machines here turning yellow on my 3D model. That's because this red alarm here is actually impacting the things that it's connected to. So we've got it's feeding the conveyor vertical and the conveyor straight. Obviously, it can't do those things because the upstream machine is broken. Um, and then we can get an event feed. I might just close this one. I can get an event feed about what's the actual data, what's the actual alarm being triggered from that machine. So we've got looks like vapor flowing over exhaust troughs. That sounds not too nice. And we've got an exhaust pipe that's clogged. Um, so yeah, this is an example of what Joe can do in a really highly scaled industrial kind of model. Um, when he's got a team that's watching this and um, going to make decisions based on this data as well. They could also do things like with the digital twin. I think the really cool bit is you can step back in time. So this is a digital representation of what's meant to be, real in the physical world in real time. But then if something goes wrong, so if a say a generator or a machine goes bad, you can actually step back in time to say 5 minutes before it goes bad and go, okay, what was the state of the temperature of that machine? What was the vibration? What was the whatever's? And really understand the root cause analysis. Um, and then you might feed that into future planning or feed that into a predictive maintenance model, something like that. Any questions about that, Casey, Rohan?
There was one question around any sensor of smoke, but this is just like a demo.
Mhm.
Yeah, look, if you wanted to have a CO2 sensor or smoke detector, as long as it integrates with MQTT, or um,
Mm.
you can trigger a bad state or get the raw data out of it. You can feed it into a model.
Nice, awesome. Like,
Sick.
I love these digital twin models, and I've seen something similar, but in the brewing industry, where they'll actually will track like how full the vessel is, like brewing temperature and deviation, because that's all really important. And also because they do get overflows, because of course the yeast is active, so it does bubble and go out of control sometimes. So being able to monitor that and like prematurely like drain some tanks into overflow tanks, so they don't have to actually clean up the whole entire the floor, because that is a real hassle apparently.
Yeah,
Yeah, I can
sticky beer
imagine.
on the floor. Yeah, thanks.
And also because it has to be food grade sanitation, right? So because they can't have, it's even more than that, because they can't have any contamination on future runs, so they actually have to like really clean everything.
Yeah, gotcha. So that was all from me from this demo. Behind the scenes here, we're actually running AWS IoT Sitewise, which is a purpose-built IoT service for industrial data, and it feeds into like a an asset model. So you can have your machines that are located on a line, that are located in a plant, that are located in a region or a country, and you can really make different decisions and drill down that way. And it's also got an inbuilt time series database as well. So um, a lot of options and a lot of different conversations that we have at the other end of town. And I'd love to hear if we want to have a chat about that one day. Um, but
I also will post a demo link just so you can play around with it in your own time, because that's the whole purpose of these. And if you do have any questions as well while that's coming through, as I'll switch screens back to Rohan's, because it has your lovely
Yeah.
name. So if you do
Yeah.
if you do want to like have questions, or like just want to dive a little deeper, do feel free to reach out to either of these two over LinkedIn. Um, yeah, they would love to hear from you. So if
Yeah.
anyone has any more questions, do throw them in now. We have a little bit of extra time, but I'm not going to bore everyone to death if we don't have any other questions. Actually, we do have one here.
So from your experience, how much money would customers save because of real time slash predictive maintenance of it? So yeah, this is a
I
I can't really share the dollar amount, but um, I would have to pull a stat of the average that we
Yeah.
would say. But we do have services pre-trained machine learning models that you can um, send all your data to do predictive maintenance on these as well. So
Mm,
it would really relate to um, your factory and your machines. And if you're already monitoring the overall equipment effectiveness, um, you know, what levers do you want to change there for that
mm.
sort of thing?
It's the classic answer of it depends, right? Like,
to give a actual targeted targeted example, the like if you're doing tractors, for example, like you won't have all of the tractor parts like on you, and for most tractors out there, they'll have their own maintenance requirements like from the actual dealer itself. So and they might not have parts as well because it's expensive to keep a whole entire tractor's worth of parts in a warehouse, and there's also different frequencies. So some parts may take 2 to 3 months to get into country for them to be able to repair your tractor, and that is the 2 to 3 months in the farmer's ecosystem. That's millions of dollars of productivity
mm,
lost because when the plants need to be harvested or the fields need to be sown or stuff like that, that has to happen on a very tight deadline. Like it has to happen when it needs to happen. So that's where a lot of this predictive maintenance and stuff really sees true value. And even the same in um, like manufacturing, for example, like a broken bearing on a conveyor belt. Like the conveyor belt's not actually doing anything; it's just passing stuff from one machine to another. But if that production line is down for 2 hours, again, that's theoretically thousands and millions of dollars worth of downtime. And also, you could be then not hitting quotas and breaching contracts. So there's a lot that goes into the maintenance and stuff. Yes.
there's a question there around use cases. So we looked at factories today. You can really apply this sort of stuff anywhere, right? Like smart buildings, like smart cities, vehicles. A lot of like worked with a lot of customers trying to do that sort of stuff. Um, Anywhere where you think like knowledge of the environment can help you optimize a process or an efficiency or whatever. Like, yeah, it's quite broadly applicable, I'd say.
Yeah, that's right. We mentioned breweries before, but there's also wineries and other beverages. Um,
Like if you can dream up a use case, then IoT or the devices can be fit into it. Even such simple things as whether or not a fence is open and closed. Um, like that can be hugely beneficial to the right people and the right use case. Cool.
Excellent.
So that's awesome. Is there any other questions? Have you explored hospitals? Um, there are some really interesting use cases around hospitals um, that I can't get into, but it's a really exciting space. I think we do have actually a blog on it, or at least a use case on it.
Not sure.
You have to search, but rest assured, there's lots of thinking about that at
Yep.
the moment.
Yeah, one of the ones that I can share because it's really common knowledge is that nurses like to hide stuff because they want to know and have stuff available to them when they want it. So going around asset management is a big one. Apparently, Leo is saying that the link to the demo site is asking for a login.
Yeah, it will be an internal link.
Oh, yep.
Ah,
That's unfortunate. Is there an external link?
I'll have to dig a bit deeper on that.
Cool. If you do want access to the link and the thing, I might actually be able to spin it up in my on my accounts and make it a bit more public. So do reach out if you do want access to that.
Yeah, or if you've got an idea of your own in your own company that you want to explore and whiteboard, reach out on LinkedIn and we can throw some ideas together.
Mm.
Yeah, definitely. The IoT space is really, really exciting, in my opinion, for like the way it can revolutionize businesses and just processing in general. Cool. I think we are getting towards the end of our slot. Um, and Leah is saying that he is interested. So Leah, do reach out to Scott Patterson
Mm.
over LinkedIn. You'll be able to find his details in the VOD as well. Unless Awesome. Thank you very much, Scott and Rohan, and all of the visitors viewers that ask questions. It's been awesome. So yeah, and hope to see you on the show at some point in the future, Scott. You're not on the
Yeah, see
you're
you
not on
next
the
time.
ban list anymore.
Redeemed.
You have earned your keep. And thank you, everyone.
Cool.
Masiwa.
Thanks, everyone. Bye.